As I'm reading through these word problems, I'm always going to be looking for my totals, and I'm going to circle those as I'm reading through it. So I've got the sum of two numbers is 21. Generally, the totals, it's going to be next to that word is or equals or something, some word to show that that's what that total is going to be. And then the second one's sentence says the larger number is 6 less than twice the smaller number. So I'm going to circle larger number. And then it asks us to find the two numbers. So this is important when defining our variables. I'm going to have two variables every time, x and y, A and b, any letters that you would like to use. So it says find the two numbers, and I know one has to be larger than the other. So I'm going to say x is my larger number, and y is my smaller number. That way, whenever I go to answer the question, when I define my variables, those should be able to complete that sentence. So when I find the two numbers, I know x is whatever that bigger number is, and y is whatever that smaller number is. Then, when I go to write my two equations, I'm going to set them equal to those totals that I circled. So 1 is equal to 21. And then it says the larger number is. Well, larger number is x. We said that over here. So we're going to set that equal to x, because I don't know what that larger number is, but that's why I found the variable, defined the variable for it. So when I have the sum of my two numbers, I've got x and y representing those two numbers. So sum means add. So I'm just going to add those two together. And then the second sentence says the larger number is, so x equals 6 less than twice the smaller number. So this is those tricky ones, less than. You got to put the minus 6's behind. Think about your age. My age is 6 years less than John's age or someone's age. Your age is less than, so that's why it's a minus 6, not 6 minus twice the smaller number. So it's 2y minus 6. Now I'm just going to use substitution, and I'm going to substitute this in for anywhere I see an x in that first equation. So that will look like 2y minus 6 plus y equals 21. Then now I'm just going to solve for y. Add 6 to both sides and combine my like terms at the same time. 3y equals 27. Divide by 3, divide by 3 to get y equals 9. That is my smaller number. Now, I'm going to go to my first equation, and I'm going to have x plus y equals 21, and you'll just substitute in a 9 for that. It's equal 21, and you'll be able to solve for x from there. And then you can easily check both of these by plugging what you get for y and what you get for x into these equations. As I read the second problem, again, I'm going to be looking for those totals. This question reads, the difference of two numbers is 15, and the larger number is 1 more than 3 times the smaller number. So again, we have larger numbers and smaller numbers. Find the two numbers. So I'm going to have x equal my larger number, and y equal my smaller number. I know difference means subtraction, but before I get there, I almost forgot to set my two equations equal to my totals. So 15 and x, because that is my larger number. See how both of those, the word is right next to them. That equal sign here is right next to them. So looking at my first problem, it says the difference of the two numbers is 15. Now when I have larger numbers and smaller numbers, you have to take the larger number minus the smaller number, so x minus y equals 15. Because if I did y minus x, so the smaller number minus the larger number, that would give me a negative, and we know that 15 isn't negative. Then it reads the larger number is, so x is 1 more than, so 1 plus 3 times the smaller number, which is 3y. Now I'm again going to use substitution here. I'm going to take this part of the equation here and substitute it in for the x up here in the first equation. So 1 plus 3y minus y equals 15. Minus 1 from both sides and combine like terms at the same time to get 2y equals 14. Divide by 2, get y equals 7. From here, you guys can answer the problem and check it, and then you'll know if you got the correct solutions. So this problem reads, William is 3 years older than Charmaine. Again, William, so William's age is one of my totals. And then the second sentence says, the sum of 3 times Charmaine's age and 2 times William's age is 76. How old are William and Charmaine? When I go to define my variables here, I need to be able to answer that question. So I'm going to say W is Charmaine, or is William's age. And then I'm going to have C stand for Charmaine's age. I want to be able to answer that question when I define my variables. Now I'm going to set my 2 equations equal to the totals I circled. So one is going to be equal to William's age, so W, and the second is going to be equal to 76. The first sentence reads, William is 3 years older than Charmaine. So we have Charmaine's age plus 3 years. The second sentence reads, the sum of 3 times Charmaine's age and 2 times William's age is 76. So I have my is 76. The beginning says the sum, so I know I'm going to be dealing with addition in the middle. Then it's just 3 times Charmaine's age, so 3 times C, plus 2 times W, William's age. Now I'm just going to use elimination. So I don't need to use elimination here. I can use substitution again. I'm going to substitute this in for W. So we've got 3C plus 2 times C plus 3 equals 76. If I were to would have used elimination on this problem, I would have had to put this into standard form. So C plus negative W equals negative 3, and dealing with negatives, it just gets messy from there. So it's easiest just to use substitution for this problem because initially it's already set up for that. So this becomes 3C plus 2C plus 6 equals 76. I'm going to combine my like terms and subtract 6 at the same time to get 5C equals 70. From here, I'm just going to solve for C, so I'm going to divide by 5, and I'm going to have C equals 14. Now from here, I'm just going to plug that into the first equation, and I'll have 14 plus 3 equals W, and that will give you William's age as well. Then you can check it by plugging it into this equation again and double checking both of their ages, and then that's how you have it. Problem number 4 reads, Alicia is 2 years younger than Bryce. The sum of their ages is 28. How old is Alicia? So I need to answer how old they are, or how old Alicia is, but I know I'm dealing with age for my variables, so I'm going to say A equals Alicia's age, and B equals Bryce's age, because we don't know his age either. Now, I'm going to read through this again, looking for my totals, which are generally next to the word is. So my first one says, Alicia is 2 years younger than Bryce. So I know one of my equations is going to need to be set equal to Alicia's age. and then the sum of their ages is 28. So I'm going to have one equation equal to A, which is Alicia's age, and one equal to 28. So it says Alicia is, A is 2 years younger than Bryce. So we need to take Bryce's age and subtract 2 from it. If we did 2 minus Bryce's age, we would get a negative number. So we'll have Bryce's age minus 2 because that's 2 years younger than. And then the last part just says the sum of their ages is 28. So I take Alicia's age plus Bryce's age to get 28. Here I'm using substitution again. So I'll be substituting this in for the A right here. So I have B minus 2 plus B equals 28. Combine like terms and add 2 at the same time to get 2B equals 30. Divide by 2 to get B equals 15. Now, you substitute that 15 back into that first equation because you can quickly then solve for Alicia's age because it's already set up for that. And you'll get 15 minus 2 equals Alicia's age. Alicia's age is 13. Then we can check it on the second equation. 13 plus 15 equals 28. The checking doesn't need to be a long process. If you just want to type it into your calculator to check it, that's fine by me. If you need to write it out, do that. Do whatever works for you. But on these, please, please, please always check them. It's really quick and easy, and you can always just know right away then that your answer is correct. So when you turn it in, you know you got that grade you wanted because you checked all of your answers. Problem 5 is very similar to problem 4, and it reads, Tyson's age is 3 less than 3 times Cedric's age. The sum of their ages is 57. How old is Tyson? Now, in the first problem, or problem 4, it only asks for one question. I think we solved for both, but make sure if it's asking that question, don't do more work than you have to. So as I'm reading through this, again, I'm going to look for those totals, which are going to be next to the word is. So Tyson's age is, that's one of my totals. How I can set my equation equal to Tyson's age. And then it says the sum of their ages is 57. So I can set it equal to 57. It wants to know how old Tyson is. Well, I'm going to say T is Tyson's age. And C is Cedric's age. When I set my equations equal, it's going to be T for Tyson's age. That's that first part I circled right here. And then equal to 57, which was the second part. It says Tyson's age is 3 less than 3 times Cedric's age. Again, this is just like that first one. When you're less than someone, you take their age minus however many years younger you are. So we're going to say 3 times Cedric's age minus 3 because it's 3 years less than Cedric's age. Then the second equation is going to just say the sum of their ages is 57. Well, we don't know Tyson's age and we don't know Cedric's age, but when we add them together, it'll equal 57. Going to use substitution again here. And I'm going to substitute this in for the T right here. I will have 3C minus 3 plus C equals 57. I'm going to add 3 to both sides and combine my like terms at the same time. So the 3's cancel, and I'll have 4C equals 60. C will equal 15 when I divide by 4 on both sides. C equals 15. I found Cedric's age, but the question is asking how old is Tyson? So I've got to substitute the C in, the 15, into this equation to find Tyson's age, which you guys can do. And then you also can check them to see if they're correct.